Yeah, that's great. Sun down the books. Yeah, here, I'm not going to this. They've done fireworks, so I'm not doing it. It's expensive.
So it's kind of a
Well, it is, but, people,
Good morning, ladies.
do bring it up to the executive council meeting.
okay. Said, like that.
There's no way you can do it now.
I think, I think, absolutely. What happens?
I'm not light influenced. Was I mean, like, did it count as light or was I just really pressing the time?
I'm sure it was light.
Okay.
Sorry. I like your earrings.
I have like 9 minutes. Can you explain something to me, Miss Gardner?
We took
I made a forum
and his parents
post.
took us around campus and showed us
I
all
still
the
don't
different.
get the question.
You want me to explain
All the tour
the
guides
question you asked?
education
Well, I can
majors or
reiterate the
communications
question.
majors. I mean, it
Oh.
makes sense.
When it comes
but
to proofs for
at the
limits,
same time, you know,
how does what I'm doing prove
I mean,
it?
I knew a lot about it.
What does it even mean when I'm
And I
connecting?
like
Dale responded back
we're
to you.
going a
Yeah, he
separate
did,
towards
but it
the
didn't answer my
centennial
question. It just
campus.
reiterated what the chapter said.
So from the very beginning,
Well, it's just like.
Are you going to state's orientation?
one? I don't know. Uh-huh.
All right.
No, I remembered it because my car payment's due tomorrow.
Yeah.
I know that sounds bad, but I remember that car.
So you guys will have class on the 11th, but not the 12th and 13th. And then ICC has no class on the 17th, and so you won't be here on the 17th.
When are we gonna take our field trip?
Yeah, what's the probability that class is canceled tomorrow?
0. I would say 0.
Why would class be
Well,
canceled?
my accounting teacher said that we're probably not gonna have class on Tuesday.
Okay, I guess it's about time to get started. The only one I see absent right now is Dylan, is that correct?
Yeah.
I'm trying to think.
But 2 minutes away.
You're gonna have to fill it.
So, what's the weather like over in Davidson?
It's
What's
just
the weather
windy.
like?
It's just cold.
Yeah, it's
It's cold and windy, and that's it.
Just depressing.
That's all we, it's not even that windy here, it's a little bit.
It looks like seasonal depression, basically.
As that goes on, we're expecting a little more. They've already canceled the public schools here. I don't know about over there, but which I don't understand that. Whatever. Except for you. Okay. Anyway, for example, our early college is closed today, so we only have just traditional students here today. Okay, so what questions? I guess we need to go over section 1.3. See what kind of questions we had.
No one in Davidson.
Good questions.
Just a little part of the underwriting.
Okay.
Can you explain a little bit more about how, after you guys factored out the inequality works?
Okay. Yeah, we can just do an example of just inequality, the absolute value, it kind of comes there, also the whole problem. Okay, so let's just talk absolute value inequality for a little bit and make sure we understand what that means. I'll start here. So you have an absolute value of x minus 4 is less than 7. I'm just going to make up an example of something. What does that mean? How do I interpret that from pre-calculus? And I interpret that as saying the distance, so distance in x and 4 is less than 7. So think of this as some number a, so this is a, and it says the distance of a is less than 7. So on the number line, I'm thinking of if this is 0, then a can be no more than 7, so this can be a in here, or a could be here.
There he is.
So A can be between 7 and -7. So this statement is translated as -7 is less than x minus 4 is less than 7. By the definition, what we interpret as absolute value as being distance from 0. That's not a formal definition of absolute value, but that's how we interpret it. So from there, I have an inequality now. It doesn't have absolute value, so I can modify it however I see fit. So for example, if I wanted to get a plus 5 right here, what would I have to add to get a plus 5, x plus 5? What would I have to add to it to get an x plus 5? I have to add 9. So if I add 9 to all sides of this inequality, then I get 2 is less than x plus 5 is less than 16. Far so good?
Yes.
Now, to translate back to an absolute value, if I wanted an absolute, if my objective is to get absolute value of x plus 5 related to some constant number, you know, this absolute value was related to a constant number. I just picked 7 out of my head. I can now relate this as an absolute value to a constant number, but I have to think in the same way. If I want the distance to be less than some number, then I got to think of this as a distance. Well, so think a step ahead. If I want absolute value of x plus 5 less than some number, some fixed number, what can I envision here? So the distance says that it can be less than 16, but to put absolute value, I've got to have a negative 16 on this side. But don't I have that kind of implied? Because if x plus 5 is bigger than 2, then certainly it's bigger than negative 16. Yeah. So now I have x plus 5 is between negative 16 and positive 16, so therefore the absolute value is less than 16. A little bit of algebra voodoo that makes that work. Magic algebra.
Where it ended up being a little right.
Everyone follow that discussion about how we can make that modification from one absolute value inequality to another by breaking it up into a compound inequality and then adjust the compound inequality as needed and switch it back to an absolute value inequality. While Joe's looking, anybody else have questions? He's trying to find a particular problem. Anybody else have questions? Davidson? God?
I have a question. So it's actually a follow-up to this. When it comes to utilizing this in a proof of a polynomial function and using it for a limit of that sort, why are you just able to arbitrarily choose a value to make the absolute value inequality? Like you made it to 7 in this instance, but why are we able to just make it like 1 in others?
That's a good question. Well, our objective is to show that we can find for any possible epsilon, no matter how small that epsilon, we're making an epsilon window that's horizontal, and no matter how small that epsilon window is, Joe, so no matter how small that epsilon window is, we want to be able to find a delta that can cause the output values to land in that window by getting close enough to the C value in the X direction. So it doesn't say that we have any kind of constraints on our delta. It's just that we want our delta to be really small so that we into that epsilon window. That being the case, I can make delta as small as I want. If I mean, we looked for earlier the maximum delta that would work to get us in the epsilon window. But delta can be, we talked about delta can be smaller than the maximum. Does that make sense? Delta can be small. So by choosing any random constant, it doesn't really matter because we can always go smaller than that. So we know we can always go smaller. We just can't go bigger than the maximum. So I can pick any constant and still go smaller than that and achieve what I'm looking for. So we just pick one because it works and it's easy to work with. Okay. We can always go smaller. Does that sort of answer your question?
Yeah, so is the maximum the thing where it's like epsilon over whatever number you found with the other absolute value thingy?
That would be the maximum, yes. Yeah, that's the maximum. When you find that relationship between delta and epsilon, that's the maximum. It can always go smaller. That's correct.
Okay.
So did you figure out what problem you want?
39.
39. They're assuming delta is less than equal to 1, which is like what I looked for. We're supposed to find the relationship between delta and epsilon. But they're not asking us to complete a whole proof, just set it up. So limit x approaches 3 of x squared minus 2x minus 3 equals 0. Limit x approaches 3 of x squared minus 2x minus, is that right? 0. Okay. And we can assume delta is less than or equal to 1, which is what we were just having a discussion on what Rezo just asked about. Again, we're going to find this relationship between delta and epsilon, but we can always go smaller than that relationship. That's just the maximum. And so by picking some cutoff boundary point, we're saying we're not going to go bigger than that point. We'll certainly go smaller if we need to. Okay, so we want to find a relationship between delta and epsilon. So what we want is we want the absolute value of a function minus the limit to be less than epsilon. So this factors as x minus 3, x plus 1. So in our limit, we're going to have x minus 3 absolute value is less than delta. This part right here is going to tell me that we're going to be given, or assume, so I have my x minus 3 already trapped by this delta. How can I use that to find out how to pick my delta with this assumption and this information here? So we know that absolute of x minus 3 is going to be less than delta. And we're trying to get to this stuff. Well, with absolute value of x minus 3 less than delta and delta less than equal to 1, then we can use that information. We can assume that this is a boundary. Like I said, delta is going to get small, and we can always go smaller than some maximum value. So we're going to say that our maximum is going to be no bigger than 1. And that's a reasonable assumption. So with that, we can put that together with this and find a way to trap x plus 1 under some amount. So if we take this right here, with this delta information right there, now we have absolute value of x minus 3 is less than 1. It's less than delta, and delta is less than or equal to 1, so absolute value is less than 1. Now play the same game we just went through over here to rewrite this absolute value into a compound inequality, modify the compound inequality to match this part. So our objective eventually, we've got x minus 3, no problem right here, that's trapped. We want to trap. Oh. We want to trap this one here. So how do we do that? How can you rewrite absolute value of x minus 3 less than 1 as a compound inequality? Jacob? Well, as I just come out, like, just convert it to a compound inequality. First step.
On -1, that's the absolute value of x minus 3. That's 1.
Yes. Now to get a plus 1 in there,
Yeah.
you're going to add 4. 3 less than x plus 1 less than 5. But I want my x plus 1 to be an absolute value statement. This is going to become, I can split these two multifactors as the product of two absolute value statements by a property of absolute value. It says the absolute value of a product is the product of two absolute values. That's always true. So again, I've got the absolute value of x minus 3. I'm taking care of that. But I want the absolute value of x plus 1. So I got to convert that back somehow to an absolute value of x plus 1. So what do I need to do? Well, certainly 3 is bigger than -5. So I have x plus 1 between -5 and +5. So that certainly means the absolute value of x plus 1 is less than 5. Okay, so this is going to be trapped by a 5. That's right. And this x minus 3 is going to be trapped by a delta, because that's what it says right there. What relationship between delta and epsilon do I need to have this come out to the statement? I need delta to be epsilon over 5, right? So delta needs to equal the minimum of either 1 or epsilon over 5. Why do I have to put the minimum of that 2? Because I have, this is establishing a maximum boundary of 1. Maximum. I can't be any bigger than that. So I have to choose the minimum. If I want both of these things to happen at the same time, then I've got to have the smaller of these two taking charge. If I pick the bigger of the two, it's like the other day when we had a delta 1 and a delta 2. Do you remember we did that with algebraic? We had two different delta values. We had to pick the smaller of the two. Well, the same idea here. I've kind of got two different delta values in a sense, but I got to pick the smaller one to make it work. Both work at the same time. I pick the bigger of the two. I pick whichever one's bigger, then the other one is not going to work. I pick the smaller, and they both. Next question. Davidson, y'all follow that too? Is there a question back there? I saw a hand go up and I can raise them.
So which one is bigger, 1 or epsilon over 5?
Well, we don't know it. But you tell me what epsilon is, and I'll tell you. The point to this game is epsilon is any epsilon. Epsilon could be 1, epsilon could be 7, epsilon could be 0.000000001. I don't know, but it has to work according to the definition for every possible epsilon that's positive, every possible one. So I don't know which one's bigger. It depends on what epsilon is. You name me an epsilon, and I'll tell you which one's the bigger or which one's the smaller.
Okay.
For any given epsilon, once you specify an epsilon, there will be a smaller and a bigger of those two numbers.
Okay.
But in general, we're just keeping it conceptual that we're going to take the smaller of the two, and by picking the smaller, we're forcing both things to happen. Does that make sense? We have to stay with the smaller to make both things happen.
Okay. Is the absolute value of x minus 3 delta because of that 0 is less than the absolute value of x minus 3 is less than delta?
Correct.
Thingy?
That's the original given. That's in your part of not your given, but your hypothesis. When you assume your starting point in the formal proof, you're going to allow your x values to be located that's trapped by that delta. And so the x minus 3, from this 3 right there, is already trapped by a delta. And so it is smaller than both of, because it's less than delta, it's smaller than both of these. So I could put a 1 right there, but that's not really going to help. It's smaller than both. But since it's smaller than both, we'll take this one because I know it's certainly that small. But I could have put a 1 there. They're both, you can use it 1 because you're going smaller than the smallest. Other questions? Y'all want to go over? Yes, ma'am. 63. Prove that this goes to infinity. Write a proof. Yes, we didn't do a proof with infinities.
No, we did not.
No, it's not that hard. It's kind of the same game. Let's see. So we're trying to prove that limit x approaches infinity of 2x minus 1 over x equals 2. Limit x approaches infinity of 2x minus 1 x. Okay. So now I got to think about the different cases we have. If we go to a fixed constant c and a fixed limit L, then we use epsilon and delta. When we're going out to infinity in the x direction, but to a fixed L value, then we have an n in the x direction, and we still have an epsilon in the y direction. So the picture, kind of a quick graph picture, is we're saying as this, whatever this function picture does, as it gets close to infinity, it's getting close to 2. So we're going to have 2 plus epsilon and 2 minus epsilon. And then we're saying that at some point out here, call it n, anything past n, the function graph will be trapped between that, those in that window. So how do we start a proof? Previously we started with epsilon. We do the same thing here. We got an epsilon window, so we're going to have to be given any epsilon greater than 0. Now we're going to choose, like we did last time with the delta, we're going to choose, but we're not going to choose delta, we're choosing an n. The n is what we got to figure out right here. Choose n equal, like I did before, I'm just going to put a reminder to myself. I got to figure out what that n is, and I'll plug it in here in a moment. So that start is the same. The only difference is we're not using delta, we're using n. Why are we using n again instead of delta? How do I know to use n, not delta? We're going to infinity, so we're not trapped in a narrow vertical window. We're trapped outside some boundary going as far out as we can imagine. The rest is kind of the same game. Zoom X is located, just that. Now, how did we locate it before? We wanted X to be a specially trap rule number. How did we locate it? Another proofs we did. It was trapped by this delta, right? Well, this time we're not going to trap it by the delta. We're going to trap it by the n. Such that X is an element of the interval n to infinity. So the start is very similar to the regular proof. The only difference is because I'm going out to infinity in the x direction, I don't have a delta vertical window. My vertical window, if you will, is infinite in length. It's just outside of this number n. And so I can't really write an absolute value statement like I can over there. So I just put it in an interval. Now the rest of it is like we've done before. We want the absolute value of a function to be less than epsilon. We don't know that yet. We got to figure that out. I'm going to kind of keep working here. Looks to me like I might want to combine fractions, so that's going to be what is that? Absolute value negative 1 over x. Did I combine my fractions correct? You're like, I don't know algebra. Okay, let's see. So 2x minus 1 minus 2 times x over x equals negative 1 over x. Now what? Well, certainly I have a negative in there that I don't really like because I'm trying to do something with infinity. So can I get rid of that negative that's in there?
I mean, it's an absolute value. So
Yes. I rewrite this absolute value negative 1 times absolute value 1 over x, which is absolute value 1 over x. Okay, now it's a little cleaner. Question, go ahead. Suggestion?
Can you move the camera to the right? I can't see.
Right. There you go.
Thank you.
See better now? Okay.
There you go. That's good.
Even though I'm not quite done with this, I'm going to wrap around because there's a podium there and it's hard to see, I think. So I'm going to wrap around my equality here. I'm getting pretty close, folks. My objective is to show that this function minus the limit is less than epsilon. I want that to happen somehow. The only thing I know that's given in my hypothesis, I'm given an arbitrary epsilon. I assume that. I get to pick this in. I haven't picked that yet. But I know that x is always bigger than n. It's in this interval. So x is somehow related to n. I've got an x right there. X is related to n. And you want this expression that we've simplified down to be related to epsilon. So how might we tie all that together so we get an epsilon out of this puzzle.
Greater than 1 over.
Now let x be 1 over, let delta, I mean, excuse me, let n be, yeah, or x be 1 over, n be 1 over x, whatever that is, or 1 over epsilon, I guess is what we want. Because you want to get this to epsilon, so if n is 1 over epsilon, then you've got a reciprocal there that handles it. So what we'll do is, we'll let n be
I get it.
1 over epsilon. So again, for any given epsilon that's positive, I get to choose my n. I'm going to choose my n to be 1 over epsilon. And then if I use that, and we know that x is a member of this, so certainly this is smaller than absolute value 1 over n.
Mm-hmm.
What I said was going to wrap around, I'm sorry. Smaller than absolute value 1 over n. Because x is a member of that interval right there. And let's see. Epsilon is positive, so we'll get there in just a second. So we can replace n by 1 over epsilon. So this is the absolute value of 1 over epsilon, which is absolute value of epsilon.
And then you proved it.
Epsilon was positive, so that's just epsilon.
Yeah.
So we have shown that you name me any epsilon you want, however close to 2 you want to be. I can find an n value far enough out that my graph will be that close to 2. Like let's say you want to be within 0.01 of the number 2. So 0.01 is 100th. 100th. So the reciprocal of 100th is 100. So if I'm out past 100, what I'm saying is if I'm out past 100 on that graph, then the function value will be within 0.01 of the number 2. I'll be clear. I put in 101 here and here, someone with their calculator, and calculate. Put 101 in your calculator, in that function. Just in the function, not the limit thing, just the function right here. Just this. Put a 101 in that. Substitute x equals 101 in here. That's it. Find f of 101 is all I'm asking you to do. 101 over 101, which simplifies to as a decimal, make it decimal as well. 1.99999. Now subtract 2. And subtract 2 from the number. Now what number do you get? 0099, which is smaller than 01. So we got it that close to the number 2 by getting out to 101. Are we follow that now?
What number did you
But
have?
since we didn't use, I didn't specify epsilon's 0.01 at the beginning. I used any epsilon. Then this is true for any epsilon, therefore it's true in general. I was just showing you an example.
Okay.
Want to follow that? Matt, you asked a question, I'll pick on you. Did you follow that? Good. Everyone else follow that?
Mm-hmm.
I'll see. Okay. What other questions? Izzo?
Are you gonna get in our case if we switch up the letters N and M, so long as it's still like correct with the answer?
No,
It's up.
that's fine. You're right. The letter M and letter N are kind of close, kind of similar, could be interchangeable in some fashion. So no, I'm not going to get too worried. If you do it correctly, like normally they use an N as an X value boundary when you're going to infinity, and they use an M as a Y value boundary when you're going to infinity. If you switch those two, I guess that's okay. Again, like delta and epsilon, we typically have delta be the X dimension boundary and epsilon be the Y dimension boundary. So I mean, as long as if you switch it at the beginning of the problem and follow it all the way through, I suppose that's okay, yeah. Did I answer your question?
Yeah.
Oh, as long as it's within a given problem, you are consistent all the way through, then that's fine, yes. Chloe had a hand up, as did Kyle. Chloe, you had yours first, I think.
Is it too much to ask for you to post the answers for the worksheets that you gave us online so we have the correct way to do it and we can check ourselves?
I don't guess that's too much to ask. I'll see if I can get that posted here sometime.
Yes.
Okay, in number 67 and 69, it says that you have to bound delta.
Yes.
What is that?
That's choosing, that's this bounding delta is like this game right here. You're going to, when you start the process, you're going to assume, well, I think delta is certainly going to be no bigger than 1. And if we use that, and remember that's like a maximum boundary, delta is going to be smaller than that, then that's fine. Remember so that's what we mean by bounding. Just pick a number. Usually we pick the number 1 as an upper bound, as a maximum of delta. And then when you finish the problem, you're going to let delta be a minimum of the number you chose here, which is usually the number 1, and then some relationship between epsilon and a constant. Once you've bounded a constant, then you'll have two things, and you'll say delta is the minimum of the two. But by bounding it, you're giving it an upper bound, a maximum bound. Does that answer your question?
Yep, thank you.
Other questions? Another.
But why can't I just choose a number? I think
Because I said so. Now say amen. Let's go on.
okay, let's just accept it.
Again, it's a matter of delta is going to be related to epsilon, and as we've seen before, there is a maximum delta that you can pick. We're going to go smaller than that by this statement here. So by picking an arbitrary bound and saying, well, I know my delta is going to be small, and picking some arbitrary bound, I'm going to always go smaller than that. As long as I'm smaller than that maximum, I'm okay.
Okay.
As long as I'm smaller than the maximum, I'm okay. If you go bigger than the maximum, then one side is likely not to work. Oh, you had another question?
65.
A limit of infinite to infinity. An infinite limit at infinity. So like 65, it says. 4, we can do like 65. So we'll go with the plus. Like that. 3x minus 5 equals infinity. So prove infinite x goes to infinity of 3x minus 5 is in fact infinity. I mean, we know that from pre-calculus. That's a linear function with a slope of 3. It certainly is, you go x goes to infinity, you know y goes to infinity. Prove it. A little more formal. So let's see. What's our game plan here? We're not getting close to a fixed value, so we're not going to use an epsilon window. We're getting close to infinity. So we got to use some bound up, and we'll usually use M for that. So than any m greater than 0. So that's like my epsilon over there. That's my y bound. Now I have to find a delta bound to go with it. I get to choose it. I don't know what that's going to be just yet, but I'll figure it out here in a second.
Is it n or is it delta?
Oh, thank you. It is not delta. Good catch. We should use an n here because we're going to infinity. Thank you. Good catch. So what next?
Okay.
What do you think we say next?
Uh-huh.
Assume. So we'll assume x is located
I don't see no x.
so that x is a member of, now this time, again, because we're using this n boundary and not a delta boundary, like before, we're just going to put x in the interval going out to infinity. So when you're going out to infinity, you can't really write those absolute value nice little info. That's the start is very similar. You either have an epsilon or an m at the beginning, and then you have either a delta or an n for your x values. The rest is kind of similar. We want the absolute value of the that to be greater than, actually, we can just put greater than. We want it to be in the interval. So we want 3x minus 5 to be greater than m. Huh.
Well, I mean, you're in the proof right now, so we don't write inequality until the end. We're just trying to.
Pardon me?
Just keep on going.
Keep on going. What do you think?
What did I have written down?
Yeah, what do you have written down? I can't see your paper.
Well, I made it like 3n minus 5. Something like that.
Oh, okay. Yeah, that's a good idea because x is bigger than n. So, so this is certainly smaller than 3 times n minus 5. So I'm not sure. Okay.
Got him. Okay.
Because we have x is at least n, then certainly this expression is smaller than that expression. I agree with that. Now what? We still got to pick our n. We got to relate n to m somehow.
Wouldn't it be equal to m? Because m would be the y value.
Oh, that's cute.
Well, we want.
Come on, Sammy, you got it. You got it.
You're there, but we want to be bigger than m. So I think I've gone the wrong way or something here because I've got a less than.
Why?
And we want to be bigger than m. We want to be out above m.
But wouldn't the part with the 3n minus 5, wouldn't that itself be equal to m? Like, it would still be greater than the 3x minus 5.
Why is it greater than x minus 5? Now that I'm
Because
thinking about it.
it's n.
Because it's between infinity.
Seems like it ought to be an easy one.
mean, 6 minus 5 is... I'm trying to imagine it, like with inputting values in it. Like, let's say
Right,
you're
yeah.
doing... Like, if you imagine that n is like the number 1, and your x value that you use 2, so 6 minus 5 is 1, and 3 minus 5 is negative 2. So why is 1 less than negative 2? That don't make sense.
Wait, where did you put?
So why couldn't you make
If n is
3n
one,
minus 5
let's say
equal to
x is
m and then just solve for n?
Let's
You
do
would
that. Okay.
get
3x
n
minus 5 equals to m, you said. I agree with that, because that's your y value. That's a good suggestion.
Can I see
Now
that
solve
again?
that, what do you get?
Okay.
Now follow that suggestion? I thought it was a good suggestion. 3x minus 5 is the function y value, and m is a y value. What does that
Yes.
mean? So let's choose n to be that. See what happens.
I can't even see anymore. What do you say on the right?
that we're saying m equal to m.
N equal to n plus 5.
A little concerned. I need to be bigger than, not smaller than. Well, okay. I get it now. So if x is in this interval, and x is actually greater than.
Yes.
Let's start over.
Got him.
So if x is in that interval, it's actually bigger than n, is it not?
Yes.
What's this? X in this interval is bigger than n. So therefore, 3x minus 5 is bigger than 3n minus 1, not smaller than that. Now if we plug in, who is it suggested to solve x over here? Who was it?
Sam.
Salami.
Sammy, thank you. So now we can substitute our n in here. So this is 3 times m plus 5 over 3.
Oh, that's beautiful. That's really nice.
Oh, oops, I forgot. We got a minus 5 here on the end. That's m. So we've got our x values, our function values. If our x values are bigger than n, then our function values will be bigger than m. Okay. Fairly simple one. Got a little dicey in there for a minute. I had our inequality direction going the wrong way. So it makes sense now that your x value is, if it's in that interval, it's bigger than the n, not smaller. Okay. What other questions y'all want to kind of handle?
I mean, this is a short one. I have a short
Bezos,
question.
I'm sorry. Yes.
So, when we're writing the proofs on the test, do you want us to include that last sentence thing with the big black square?
Yeah, I guess really you're supposed to. And I'm sorry I didn't do that today. The book does make a point about that, including a summary with a square that says this is the end of my proof. You know, like the stamp on seal of approval says.
So is a square like a big period?
Leave off a square. I'm probably not going to worry about that too much, but you really probably should summarize this. I didn't finish it. What should we summarize here? That's whenever x is greater than n, we get f of x greater than m. To me, that shows it's going to infinity, but whereas x goes to infinity, then fx does.
Oh, that's cute.
X greater than n means f of x is greater than m. And if you don't put a black square on there, that's so I need to write solution sheets. Okay, I'll try to get that done.
Needs to write
I
what?
do have a class right after this, so I can't promise exactly when I'll get it up, but I'm going to have a meeting right after that class.
Well,
I'll try to get up as soon as I can. That's close.
On our test, do you want us to show our work like off to the side of the proof and then write the proof very like neatly, but then also have our work off to the side?
Yes, that would be what I would be looking for, is exactly what Chloe said. Your formal proof portion should be identified as a proof, like I've done over here with, you can say, here's my proof, and then just it should show the formal proof process of stating the hypothesis and then showing that the conclusion comes about. Any side work, scratch work, should be shown but identified separately from the proof. So somehow indicate that I've got some scratch work here and I've got proof. So yes.
Are we allowed to use scratch paper, or do you want it to be contained within the realms of the printed test?
Well, I mean, yes and yes.
Sweet.
If you can contain it in the realms of the printed paper, that's less pages that the disclaimer has to scan, and less pages fewer pages that I have to print off. But if you need another extra piece of scrap paper or something to do some of that, that's fine too.
I'm just really insecure about my writing now because it did not scan well at all on the last test, and I'd like to, be an ink man, but I kind of want more paper space to be an ink man.
Well, if you need more paper space, then that's fine. If you want to use, if you use ink or something, make sure you use a very soft lead pencil that writes darker. If you use a hard lead pencil, they don't write as dark. So a softer lead pencil works, or an ink. For those in having to scan up, here y'all find it.
That'd be
Well, the
wise.
scan you can miss some of it if you saw it.
Are we allowed to keep it?
Yeah, we'll do that again. ICC needs to start 15 minutes early because Maddie has to get back to the high school. I guess, Dave, you work better to start on time and end 15 minutes late. Is that correct?
Yes.
Are we the 15 minutes late club? Yes. Okay.
So Dale, what are the weather people saying about the storm in your area tomorrow?
We're gonna achieve immortality.
This morning it was, we're supposed to get massive rain starting tonight through mid tomorrow.
Yeah.
High winds.
Supposed to have here high winds, some stronger winds, not hurricane strength. Last I saw was like maybe gusts of up to 30 miles an hour, which is pretty strong wind, and a lot of rain. So far, they haven't given any indication that we'll be closed. If ICC gets canceled because of the weather, then our alternative plan will be that we'll take the test on Wednesday. If we get canceled, Davidson, we'll plan you to do the same. Everyone just take an extra day of preparation, I guess.
Oh my gosh. Is it wrong to ask about test composition? Like what the test is going to be made up of?
What's the test going to be made up of? It's going to be covering sections 0.5, 1.1, 1.2, and 1.3. That's what's on the test.
Is it okay if I ask how many proofs I should be expecting? A fair amount?
I would say, yeah, fair amount. What I consider fair. Maybe not what you consider.
God,
I would certainly expect at least a linear proof. at least a quadratic proof. Also some kind of going to infinity type of proof or something like that. Maybe not a double infinity, but at least one of the infinities you ought to be able to handle. So there's a minimum of 3 that I've named. So.
How many questions is this test?
I don't remember. Several? More than 5 and less than 100.
More than
Absolute value of number of tests is less than 50.
I'm writing this in like compound inequalities. Questions is less than
So number of test questions between -50 and positive. Pick a number.
It's reshaping my mind.
Certainly other things to remember, just to remind you as you study, we started with the process of limits with tables. So those kind of questions ought to be really easy. Graphs, looking at graphs. So those also ought to be easy. The hard ones probably will be the formal proofs. But I'm not expecting anything really crazy. Just basically, if you can replicate what we've been doing, you should be fine on the proofs. Now, some of the other questions you may have to think a little more. That's the distinction between an A and a B in my mind. So.
Okay.
Is on.
When is this lecture today going to be put up? Is it possible to hear it by today as well, like in video?
Yeah, we can get that posted today. Well, as soon we have to wait on your end to post it on your website, and then we have to download it to our website, and then we have to upload it to YouTube, and then download it to our. I mean, it's just yeah. But we can get it up today for
It
sure.
should be no later than 2.
No later than 2. Hopefully earlier than that.
That's fine. I'm a patient man.
Good.
Are you?
No.
A little.
No.
A little.
No.
Yes.
It's always the hope of that, right? You still have some time if you have more questions or want to do another example or something. It's up to y'all.
Oh yeah, that'd be cool. Can you do the M
That's
thing?
hang on. Is that Dylan?
Yes. Could you do 33?
33. Okay, look at 33. Go here in the middle. 33. X goes to 0, 5x squared minus 1 equals -1.
I mean, that makes sense. If you think about it graphically, it's just like a vertex.
So limit x goes to 0 of 5x squared minus 1 equals -1. What are the directions for this problem? Are we to formally prove it or just find a relationship? So it says to use algebra to find delta in terms of epsilon. So basically, what they're saying is, like we did over here, when we said n was in terms of epsilon right there, it's like we're finding that part. So we're all but proving it. We're just not finishing out the proof. We've got to get that choose part done. So if we want to be close to -1, then we're going to have an epsilon is greater than 0. And then we're going to have to, so I'm just almost replicating the proof. We're going to get to choose our delta. And in that, then we're going to assume that and then we want, at the end of the game, we want the function minus the limit less than epsilon. So we got to figure out how to tie all these two together so that we can know what delta is in terms of epsilon. This looks like, if I simplify my algebra, 5x squared
Mine is 0 for convenience.
5 times absolute value of x squared. This is, again, we're wanting this to be less than epsilon. So what's the tie between the idea, again, it's almost like we're starting a proof, we're not really going to finish it. What's the tie between this statement and this statement? If we can tie these two together somehow, and that tells us the link between epsilon and delta, which is what we're trying to figure out. So what's the tie between them?
I mean,
Dylan, you see it?
Yeah,
What's the tie?
the X.
Oh,
Yeah.
yes.
Yes.
God.
So this is the same as saying absolute value of x is less than delta because there's a 0 right there. But we're almost there because now I can rewrite this as a product of x times x, and by the product rule of absolute values, I get, bring it up so we can all see it here. I can write this as 5 times absolute value of x squared less than epsilon. So we're real close there now. So let's see. Absolute value of x squared is less than epsilon over 5, maybe. So absolute value of x is less than the square root of epsilon over 5. And I think that's the link we needed. Now we've got two things that look pretty much the same, so I can say that delta got to be square root of epsilon over 5. Does that make sense now? Bill?
Yeah.
Everyone else make sense to you?
Yes.
So you could, in this game, we could now actually write a proof. The hard part usually is finding that relationship between delta and epsilon. The rest of it is just kind of filling in, and like Reza said, kind of following the plan. The plan is purposeful in that in advanced math, proofs are what we want because that's showing that for all possible cases this is true. And so there's a very particular way we write the proofs, but finding the delta and epsilon is the key to it. The rest of it is just kind of a set pattern of how we write a formal proof. Recognizing that if there's a point to it, it's showing for all epsilon.
Okay.
The questions real quick, are we good about this? Dang, I hate to not give you your full money's worth. I guess since you got more than you paid for a couple days last week, we'll call it square today and knock off a couple minutes early. So hope we don't get stormed out here. I know how excited we are to take our test now.
Yeah, so excited.
Till tomorrow.
Can you walk through and
Actually, the better way.
We're good.
So that's like goes to infinity.
I'm gonna have to go sign up for
How much time?
Are you gonna do the whole person?
I just get a sense of how to do it.
Not the worksheet, like the book stuff. I didn't make the connection that everything that was not like asking for a proof were parts of proofs, basically. So I struggled with it. Because I understand proofs.
So here's
I
the
think
thing.
I understand.
Instead of, like, when you have this M, when you have this M here, you have that instead of epsilon. Right? And so you, instead of your first thing being epsilon, you're gonna say, let M be greater than 0.
Okay, so given
This is basically, you don't have to, right?
yeah, so given m is greater than 0, here is
I mean, I
part of
Well, no, it'll be after value.
But I mean, I was born on
assuming x. I mean, is it even an absolute value because of some derives? I'm pretty sure I kind of did this in my head, where if it was like
So
this,
it'll be x plus 2, x minus 2.
this would be x plus
Yeah.
okay, basically. So it wouldn't even be an absolute value, would it?
Well, I guess it kind of would because it would have to start at 0. Because you'd have to make sure it's always
Okay,
positive.
so assuming
So it would be 0 is less than the absolute value of
Today, our treat earn a gift card when you spend $100 or more. $100, $25 gift card,
okay, and then
$75.
Oh,
$50
that's
gift card.
you get
No, why is that not equal?
and
so you
so
have that, the 1 over x plus 2.
1 over x plus 2,
Less than epsilon.
or there's no epsilon though. Less
Or
than m,
less than n, yeah.
less than m, and then
And then that x plus 2 is basically your delta, right?
so you could just gonna solve for that. So x plus 2 is less than m of 1 over m.
And that's going to switch to
Did you do all 20 questions?
do reciprocal.
Really? Oh my gosh. So delta is equal to 1 over m.
This.
That's your answer.
I have sons.
Oh, yeah, and then I gotta do it down here for some whatever reason. 1 over x plus 2. Right, is that what I start with?
Absolute value.
Is equal
Do you have
to
one for
1 over m.
Mm-hmm. No, delta. 1 over delta. So yes, this would be. Which is,
Oh, this is 1
yeah.
over delta,
Yeah.
which is equal to 1 over m,
Right,
which is equal to m.
right.
And then thingy thus the wind x approaches -2.
Right.
2 equals infinity. Given depth of wind.
Yep.
Square.
Yeah.
Yeah.
Sweet. Turn this stuff off right quick.
I made Dale laugh today. I feel pretty good about it. It accomplished my goal.
Yes. Yes.
How important is it to know how to graph the limits on your calculator with the window?
The graph the limits on your calculator, like on that first sheet that we did.
Okay, basically. 1 second.
So like on this sheet where it had the tables, is that what you're saying?
No, the one after.
This?
That one, yeah. How important was it to know how to do it on your calculator?
Oh, not really.
Okay.
It was more important to know, like, in general, because, like, when I was going through these, I would graph them in general.
Okay.
So I
So
would
that's
do,
what
like,
we were supposed to
the
do.
original graph, and then I would do, like, a visual of the zoomed-in graph.
Yeah, my dad and I I tried doing it by that, and we couldn't figure out how to do it on the calculator.
Yeah, I didn't
But
do
we-
that.
But we could do it without the calculator.
Yeah, like, I would do, like, 3 graphs just
Okay.
visually, not on the calculator.
Okay.
But those tables on the
Yeah.
first sheet, those are on the calculator.
Okay.
Does that make sense?
Yeah, those are easier to do
Yeah.
though.
Yeah.
So I didn't make assumption. Yeah. Question, for example, number 35, it simplifies to absolute value of x minus 2. So x minus 2 is less than x squared. So then you assume that it was given into the
Well, in this
or
case, you
bounded
don't,
values.
because you get that delta squared, so it would just be the square root of epsilon.
Yeah. So you always plug in delta if you're in that situation.
As long as this matches. Like, if it were x minus 2 and x minus 3, then you couldn't, and you would have to find a bound. And that's when you would do the minimum of 1 and whatever it was. Does that make sense?
What does the G, or not G, sorry, delta is less than or equal to 1, what does that, how does that make it, what does that play into in this equation?
In this one, you don't need it,
Okay.
because you don't have two things that are different than delta. But like in this one,
I know,
what's the-
question, what, we have one in
where you
class
had to
39.
find that minimum, where you had to bound delta,
That was question 39. It's today,
39?
I believe.
So whenever it has something like that, it'll be the
Yeah,
minimum.
yeah, because here you have the two different ones. You had the x minus 3, which is delta, so that one gets trapped by delta, and then the x plus 1, which is different.
Okay.
And so you've got to come off to the side and figure out, well, okay, that's where you have to add 4 to get, so you have this x minus 3 to begin with, but you have to get it to equal x plus 1. And that's where you add, that's why you choose to add 4, right? And you set that delta less than or equal to 1. And then you have the minimum.
Was the x minus 3, was that like equation that they're given, or?
That came from this, the limit as
Okay.
it approaches 3.
Okay.
And off of that, wherever we were changing the inequality to x plus 1, or whatever, for the very beginning of class, we did, I think it was absolute value x minus 4 is less than 7, or something like that.
Yeah.
And then he added 9 to it to get x plus 5. Where did x
I
plus 5
think he
come
just chose delta. I think he just chose, I think he said as the limit approaches 5.
from? Oh, okay, that's probably why I missed that in here.
Yeah, so it would only be, you would only want to get the x plus 5 if that's what your limit is approaching.
Okay, got it.
So it would be like, as the limit approaches x, as the limit approaches negative 5, and that's why you would want x plus 5.
Okay, that makes sense. I just wasn't sure where that came from.
Yeah,
I
so
just
you
did
would
it here.
always start with whatever that is.
Okay, and then you could, well, let's say you
And then
started
you
with
add to
this.
get that on each side.
Let's say you started with this, just theoretically, and you had this and that, or this and that inequality, or absolute value of x, I guess, minus 5, or plus 5.
Yeah.
Plus 5. So that,
And you
those were
found that
together.
by delta.
Yes.
Yeah.
Okay, got it.
And so you have that, but if you came up with that, then you would have to add to get
Yeah.
that.
Okay, that makes sense.
Question 67 and 69, he's talking about the delta was bound.
Yeah, and it's because it's a quadratic, because these are quadratic.
Okay.
And so when you get those two
So it's just saying the
binomials,
answer's
one of
gonna-
them will be delta, which you bound by 1,
Okay.
and the other one will be tied to epsilon.
Okay, so, okay, that's just
And
determines
that's
how
just,
we write the
yeah,
answer. Okay.
yeah, that's just what they're asking for.
Why is there always a 1?
Because that's what you choose arbitrarily. That,
Okay.
so if you would choose 5 to be here, then you would bound it by 5.
Okay, got it.
But your epsilon would be different.
That should be
I mean, you can choose any number, it's just easiest to choose 1.
See, that's the thing, this has so much choosing, and I don't understand, if you're trying
Right,
to
like,
prove something,
if
how
I
can you
if I
choose?
chose 2, right,
Yeah.
then I would bound it by 2, but this would be bounded by, I mean, this would be a 2, and then you would get totally different numbers for epsilon. So it doesn't matter what that number is,
It's equal.
because it's always gonna be those same bounds. Like, the bound will always be the same length, I guess. Does that make sense? Kind of.
I don't know.
1 is just the very easiest number to choose for your bound.
Okay, that makes sense. I mean, it's one.
Oh, yeah. There's a hurricane tomorrow.
I would definitely know, I would go back and look at those number 1s also,
Using just the calculator, or what do you mean?
like all those true-false questions,
Oh, yeah, those are quite.
like he had on test 1.
Definitions. Do you have any other questions? Wow. Within the first like 6.
I made a document with them. I know
And then they say,
You actually came up with that, like,
I have done the ACA
No, I'm talking about the bio.
Wow, yeah, I went through my book and my textbook and I actually have the answers.
Thank you, Mr. Leader.
No problem. You guys will do fine.
Yeah, I'm sorry.
You're fine. I'm just gonna change the lights on. You need the lights.